technique used when decision variables must be in whole numbers, and it is commonly applied in areas such as scheduling and diet planning. In this study, a campus dietitian is assigned to prepare a healthy evening meal for college students at the lowest possible cost, while still meeting all nutritional requirements. This problem is modeled as an integer programming problem and solved using an Excel solver.
Problem focus on design a cost-effective college meal plan using linear programming. A campus dietitian is responsible for preparing a nutritious evening meal for students while keeping the total food cost as low as possible. There are 7 available food items, and each item contributes different amount of calorie, iron, fat, protein, and carbohydrate. The meal plan must satisfy several nutrition requirements, including providing between 900 to 1,500 calories, at least 4 milligrams of iron, and at least 26 grams of protein, while limiting fat and carbohydrate to not more than 50 grams each. To solve the problem, we define decision variable representing quality of each food item, use the formulate an objective function to minimize total cost. All nutritional requirements are included as a constraint. Using Excel solver with the simplex LP model, we obtain the optimal combination of food item that meets all dietary constraints at the minimum possible cost.
The objective of this study is to minimize the total cost of the meal plan while ensuring that all dietary and nutritional requirements are met. Since food quantities are assumed to be selected in whole number units, integer programming is the most appropriate method for solving this problem. This problem takes place on a small college campus in Idaho, where the responsibility of planning students' evening meals is assigned to a dietitian. The meal must contain between 900 and 1,500 calories, provide sufficient protein and iron, and stay within the limits for fat and carbohydrates. There are 7 available food ingredients, each with a known cost per pound and specific nutritional values. The task is to determine how much of each food item should be included so that all nutritional requirements are satisfied at the minimum total cost. The decision variables represent the amount in pounds of each food item selected, and all variables are restricted to non-negative integers. The objective function is to minimize the total cost of the meal. The constraint ensure that the nutritional requirements for calories, protein, iron, fat, and carbohydrates are satisfied. This complete model is then solved using Excel solver.
Assalamualaikum. My name is Siti Nohesrina binti Zuraini and my matrix number is 314572. So to solve our optimization model, we utilized the Microsoft Excel Solver add-in. Our primary goal was to minimize the overall cost of the meal plan while meeting all nutritional needs. The quantities of food served as our decision variables. To keep the plan realistic, we applied integer constraints and integrated all necessary dietary requirements. We then apply the simplex LP method to find the most efficient, cost-effective solutions.
How to solve our problem using Excel solver. So firstly, we press this Z, minimize Z, and we put the formula, which is sum product, and we highlight the min Z column, and then we set our solution place. Okay. Now for the left hand side, we use the same formula, which is sum product. Then we highlight this constraint, then comma with this solution and also this solution, and enter. Then we drag all over this to make sure it's all right. So the last step, which is using the solver, we first set the objective, which is Z, min Z. Then we make sure to set this to minimize, because our problem was to minimize the cost, and to minimize the cost of food. Then for the changing variable cell, we highlight this solution cell. Then we add the constraint, we add this left hand side, and for the constraint we choose the right hand side. Then we choose the left hand side for the greater than, and the constraint which is this one. We then we solve. Then we get the answer.
Now, let's discuss the final result of our model. Using Excel solver, we identify the cheapest combination of ingredients that successfully satisfy every one of our nutritional requirements. The result emphasizes low-cost, nutrient-dense staples, specifically beans, spinach, and potatoes. These items prove to be the core answer to our primary question: how can we maintain a balanced, healthy diet even when grocery costs are high? Ultimately, these findings indicate that integer programming is a highly effective method for decision support in nutrient planning. It allows us to bridge the gap between mathematical precision and the practical need for affordable, healthy eating. In conclusion, this case study successfully demonstrates how integer programming can be a powerful, practical tool for everyday decision making, specifically in the context of meal planning. By developing a structured mathematical model and leveraging Excel solver, we prove that it's possible to balance complex dietary requirements while achieving the lowest possible cost. It removes the guesswork and provides a data-driven solution to nutrition. Finally, it's important to remember that this framework isn't just for food. The same logic of optimizing limited resources can be applied to logistics, scheduling, and budgeting across many other real-life industries. Thank you for your time.